Our first method is solving by factorization. This technique relies on a fundamental principle called the zero product property. Essentially, if two numbers multiply together to give 0, at least one of those numbers must be 0. When we factorize a quadratic, we are rewriting the expression as a product of two linear factors. If that product is set to 0, we can solve for each factor individually. Let's apply factorization to this equation. We need to find two numbers that multiply to the constant term 6 and add to the coefficient of x, which is -5. Thinking through the factors of 6, we find that -2 and -3 fit both conditions. We can now rewrite the quadratic in its factored form. According to the zero product property, we set each bracket to 0. Solving these simple linear equations gives us our two solutions. Notice how we converted a complex addition problem into a simple multiplication problem involving 0. Next, we look at completing the square. This method is incredibly powerful because it works for any quadratic, even those that cannot be factorized. The goal is to transform the equation into a perfect square equal to a constant. This form is particularly useful in the IGCSE syllabus because it directly reveals the turning point, or vertex, of a parabola. To begin the general process, first divide by a if necessary. Then move the constant term to the right side of the equation. Finally, add b divided by 2a, all squared, to both sides. By adding half of the x coefficient squared to both sides, we force the left side of the equation into a square that we can then easily solve by taking the square root. Let's work through completing the square step by step. First, we move the constant term to the other side of the equation. Now, we look at the coefficient of x, which is 6. We take half of this value, which is 3, and square it to get 9. We add 9 to both sides to maintain the balance of the equation. Simplified, we have x squared plus 6 times plus 9 equals 16. The left side is now a perfect square. We can rewrite it as x plus 3, all squared. To solve for x, we take the square root of both sides. Remember, when taking a square root of a constant, we must include both the positive and negative results. This gives us two paths, either x plus 3 equals 4 or x plus 3 equals -4. So we find that x equals 1 or x equals -7. By completing the square, we have found the exact roots and, as a bonus, we know the vertex of this curve is at -3, -16. The third method is using the quadratic formula. This is derived directly from completing the square on the general form and is a reliable fail-safe for any quadratic equation. For any equation in the form ax squared plus bx plus c equals 0, we can simply substitute the coefficients into this formula. The part inside the square root, b squared minus 4ac, is called the discriminant. It tells us the nature of the roots without having to solve the entire equation. If the discriminant is greater than 0, we have two distinct real roots. If it equals 0, there is one repeated real root. And if it is less than 0, there are no real roots. Looking at the graphs, when the discriminant is positive, the curve crosses the x-axis twice. When it is 0, the vertex just touches the x-axis. When it is negative, the curve never reaches the x-axis, meaning there are no real solutions. Let's use the quadratic formula to solve this. First, we must identify our coefficients carefully. Notice that b is -7. It is vital to include the sign. Now, we substitute these into the formula. Let's simplify the terms. -7 becomes +7, and -7 squared is 49. Since the square root of 25 is 5, we have two possible values for x. For the first solution, we use the plus sign. For the second solution, we use the minus sign. Our final solutions are x equals 3 or x equals 0.5. Let's look at a typical exam question. Find the values of k for which the equation x squared plus kx plus 9 equals 0 has real roots. In Cambridge exams, you are often asked to find a range of values rather than just solving an equation. This question specifically mentions real roots. For roots to be real, they can either be two distinct roots or one repeated root. Therefore, our discriminant, b squared minus 4ac, must be greater than or equal to 0. Let's identify the coefficients. A is 1, b is k, and c is 9. Now, substitute these into the discriminant inequality. K squared minus 4 times 1 times 9 is greater than or equal to 0. Simplifying this, we get k squared minus 36 is greater than or equal to 0. To solve this quadratic inequality, we first find the critical values where the expression equals 0. K squared equals 36, so k equals plus or minus 6. By looking at the graph of k squared minus 36, we see the regions where the values are positive. The values are greater than or equal to 0 when k is negative 6 or less, or when k is 6 or more. Always check if the question says real roots or distinct real roots to know if you should include the equal to sign. Let's look at 3 common pitfalls that can cost you marks in the exam. The first is failing to handle negative coefficients correctly, especially the negative b term in the quadratic formula. If b is already negative, negative b must be positive. For example, if b is negative 7, negative b is positive 7. Second, many students type negative 5 squared into their calculator and get negative 25. Remember that any real number squared is positive. Use brackets. Open bracket, negative 5, close bracket squared. Finally, when taking the square root while completing the square, students often forget the plus or minus sign. This leads to missing an entire solution. A quadratic equation will almost always have 2 potential solutions. Don't leave one behind. To secure those top marks, here are a few professional exam tips. Always check if an equation can be factorized easily before jumping to the formula. It's faster and reduces the risk of calculator errors. If the coefficients are large or involve decimals, use the formula immediately. Even if you use a calculator, write down the formula with the numbers substituted in. If you make a small calculation error but have shown your substitution, you can still earn method marks. Cambridge examiners are strict on rounding. If the question doesn't specify, give non-exact answers to 3 significant figures, but give exact fractions or surds whenever possible unless told otherwise. Never start solving until your equation is in the standard form, ax squared plus bx plus c equals 0. If you have terms on both sides, you must move them first, or your coefficients will have the wrong signs. It is time to test your understanding. Please pause the video now and attempt these 3 questions. Easy. Solve x squared minus 8 times plus 15 equals 0 by factorization. Medium. Solve 2 times squared plus 8 times plus 3 equals 0 by completing the square. Give your answers in surd form. Hard. The equation kx squared plus 4 times plus k minus 3 equals 0 has no real roots. Find the range of possible values for k. Take your time with the hard question, focusing on the discriminant. Once you are finished, resume the video to check your solutions. Let us go through the solutions together. For the first question, we look for 2 numbers that multiply to 15 and add to negative 8. These are negative 3 and negative 5. Therefore, x equals 3 or x equals 5. For the medium question, we first divide by 2. Then complete the square by adding and subtracting half of the coefficient of x squared. Solving for x, we get x plus 2 squared equals 5 over 2. Taking the square root gives us negative 2 plus or minus the square root of 10 over 2. Finally, for no real roots, the discriminant b squared minus 4ac must be less than 0. Expanding and simplifying the inequality gives us k squared minus 3k minus 4 is greater than 0. Factorizing gives k minus 4 times k plus 1 is greater than 0. The range is k less than negative 1 or k greater than 4. Let's go through the homework solutions. For the easy question, solve x squared minus 8 times plus 15 equals 0. We need factors of 15 that add to negative 8. These are negative 3 and negative 5. Writing this in factored form, we get x minus 3 times x minus 5 equals 0. So, x equals 3 or x equals 5. For the medium question, solve 2 times squared plus 8 times plus 3 equals 0 by completing the square. First, divide the whole equation by 2 to make the coefficient of x squared 1. Move the constant term to the other side. X squared plus 4 times equals negative 1.5. Add 4 divided by 2 squared, which is 4, to both sides of the equation. Now we factor the left side into a perfect square. X plus 2 squared equals 2.5. Take the square root of both sides, giving x plus 2 equals plus or minus the square root of 2.5. Finally, x equals negative 2 plus or minus the square root of 2.5. The hard question asks for the values of k such that kx squared plus 4 times plus k minus 3 equals 0 has no real roots. No real roots means the discriminant, b squared minus 4ac, is less than 0. Here, a is k, b is 4, and c is k minus 3. Substitute these into the discriminant formula. 4 squared minus 4 times k minus 3 is less than 0. Expanding the brackets, we get 16 minus 4k squared plus 12k is less than 0. Divide by negative 4. Remember to flip the inequality sign. This gives us k squared minus 3k minus 4 is greater than 0. Factorize to find the critical values. K minus 4 times k plus 1 is greater than 0. Our critical values are k equals 4 and k equals negative 1. Looking at the graph of this quadratic, we can see where the curve is positive. The expression is greater than 0 when k is less than negative 1, or when k is greater than 4. To summarize today's lesson, here are the key takeaways. 1. Factorization relies on the zero product property. 2. Completing the square is excellent for finding vertex points. 3. The discriminant tells us the nature of the roots. And 4. Always flip your inequality sign when dividing by a negative number. To summarize our lesson on quadratic equations, first, always identify the best tool for the job. Use factorization for simple integers, completing the square to find vertices, and the quadratic formula for everything else. Second, remember that the discriminant is your diagnostic tool. It tells you if you have 2, 1, or 0 real roots before you even begin the full calculation. Third, consistency is key. Never identify your coefficients until the equation is equal to 0. Finally, in the Cambridge IGCSE, your method is just as important as your final answer. Write down your substitutions and each logical step to ensure you achieve the highest possible grade.